video, we're going to take a look at how the speed of an object can be traveling in a circular motion. We're going to be looking at two different kinds of speeds, linear speed and angular speed, and see how they are actually related to each other. One thing that you've learned in previous courses is that distance is equal to rate times time. Right? D equals RT basically. And distance is measured in terms of miles, and rate is given in terms of something like miles per hour, and time can be given in something like hours. This is just an example of units of measurement. So if you think about how you can rewrite this equation, the D equals RT, then if you actually move the T over to the other side, divide both sides by T, you can see that what you'll have is distance divided by time is equal to rate. And rate is really the same as speed because you can think of miles per hour as a rate, and that's how fast you're going. So that's the speed. If you're thinking about how an object can be going around a circle, remember that in terms of its distance, it's not such a clear-cut distance, because what we're referring to here is if we think about a circle, and if you take a look at this distance, that distance is curved. And so that arc length, I know that in the previous video we called it L, but we're going to kind of change that letter to the letter S in this video here. Okay, so the arc length is S. And so therefore, if we wanted to find the speed around a circle, then we'd actually need to use this curved distance rather than more of like a straight distance, right? A straight distance would be the value of D. So we're going to have to use that value of S instead, okay? So knowing that, with the same formula that we have up here, we're just going to change that distance into a curved distance, or the arc length. So S is going to be divided by time to give us how fast we're going. So V represents the speed. And we use the letter V because typically you might be associating that word with that letter with the word velocity. And so velocity kind of shows us how fast we're going. And so that V can be thought of as speed. Okay, so you can write it that way, or you can also say that S is equal to V times T, right? This is the same kind of scenario here. D equals RT. But remember, all we're doing is we're just changing that linear distance, which would be measured with a line with a ruler, into more of an angular distance, and that's going to be represented by our arc length. Okay, so we have this formula as well. All right, so going to our box here, we're just kind of formally putting into words here that the linear speed V is defined as the arc length S divided by T, time. Okay. Now, if we want to find the angular speed, it's along the same idea here. You're finding that how fast it's actually moving through an angle, then the angle itself is what should be considered, the theta, rather than the arc length. We know that the arc length is really measured over here by the S value. So if we're thinking about it in terms of theta, we're seeing how long does it take to get through a certain amount of theta for a certain amount of time. So our angular speed, this is actually what we call omega, and omega is found very similar to what we saw up above in our previous formula. We're just seeing for every certain number of degrees, theta, how long does it take? So theta divided by time. So it's a very similar formula. Now, if we join the two things together, we can actually see how linear speed and angular speed are actually related. One thing that we have already established is that V, the velocity, the speed, is equal to how far you're going, the arc length, divided by the time. Remember, it's like measured like miles per hour, something like that. Okay, so it's S over T, and recall from a previous video, we said that the arc length, S, can be thought of as, in terms of radians, R times theta. Okay, so what we have is we can establish a new formula, R theta over T. And then, kind of separating the two, we can say that let's have that theta and T group together, and then leave that R alone. And then with the theta and T grouped together, we just saw how theta and T can be represented by the angular speed omega. And so that's what we're going to do. We're going to substitute that with the omega. Okay, so we also have this formula here that V, our speed, the velocity, is equal to R times omega. Okay. All right, so, and remember that the R in this case, because we're talking about a circle, is representing the radius. Yeah, it's the radius of the circle. Okay. All right, example 11. Let's go ahead and put some of these formulas into practice. Find the linear speed of an object. So Earth rotates on an axis through its poles. The distance from the axis to a location on Earth, 40 degrees north latitude. What that means is if you measure from the equator and you go 40 degrees north, meaning you go up like that, you'll be at this spot on the Earth. Okay, it says that the distance from the axis, so the axis is here, to a location on Earth. So if you can imagine, my line is kind of like going through Earth right now. It's like in the middle, inside the planet. And I'm finding how far that distance is. That distance is 3,033.5 miles right there. Okay. So therefore, a location on Earth at 40 degrees north latitude is spinning on a circle of radius 3,033.5 miles. I'm going to try to paint you a picture here. I want you to not think about every piece of this Earth, but only just focus on this point. And what I want you to imagine is that we have this point in the center of the Earth, and think of the other point kind of like attached to a string. And what this is doing is, because you know that the Earth rotates, we see that the Earth is spinning around in a circle. So this point is spinning around in a circle like this. And we know that the radius from the axis to that point on Earth is 3,033.5 miles. Okay, so that's what we're dealing with here. And what we want to find out is we're computing the linear speed. So how fast is someone on Earth going at this point, like on the Earth? Okay, so at 40 degrees north, how fast is this person going? So if we think about it, if you think about how a person is spinning around the Earth, it's going to take them this long to actually get back to the same location. And hopefully what you're thinking right now is, oh, well, that's basically like finding the circumference of a circle. So circumference, we know that's equal to 2 pi r, and the radius in this case being 3,033.5 miles. Okay, we can find out how far this person has to travel. Okay, so I'm just going to go ahead and open up my calculator right now. Okay, and let's clear this actually. All right, so what we're trying to find here is 2 pi times 3,033.5. And so we get a value, the person has traveled a distance of 19,060.04 miles. Okay, so that's how far, if you're spinning around the Earth, that's how far that person has traveled. And think about it, like in terms of how long it takes, well, we know that, the Earth revolves. You create one revolution for every 24 hours. That's how you go from day to night, right? So it's going to take a full day. It takes one full day to complete one revolution. So if we think about how we want to find the velocity, v, which is technically equal to s over t, we have now found that it's going to take 19,060 miles to actually get around the Earth at that point. So that's going to represent our s, our distance, our arc length, right? Our arc length is going around the circle at a length of 19,060.04 miles. And then we think, okay, well, how long does that take? Well, it takes one full day to go around the Earth, and so therefore that's going to be the same as 24 hours. And the reason why I want to write it in hours is just so that I can have a unit of measurement in terms of mile per hour. Okay, so now I'm going to go ahead and calculate, oops, oh, sorry. I'm going to go ahead and calculate, I keep pushing the wrong one. I'm going to calculate the speed. Okay, so we have our value already. We're going to take that and divide it by 24 hours. Oops. Take my answer and divide it by, nope, that's not how I do. Divide it by 24. There we go. Okay, so it looks like our speed, our linear speed, is going to be 794.1, let's call it 0.17 miles per hour, just like that. Okay, and that's all. for this video.